He's one of the country's foremost experts in nuclear weapons policy, energy policy, security policy, environmental policy. He's director of the Woods Hole Research Center, whose mission is to understand the causes and consequences of environmental change and the basis for policy solutions for a better world. Working both locally and internationally, that center, that research center, assists communities with resource management and helps to promote sound policies. So, ladies and gentlemen, I ask that you join me in welcoming a very dear friend and one of our country's greatest resources, John Holdren.
Well, thank you, Jane, for that very gracious introduction. It certainly is a great pleasure and an honor for me to be giving the Louis Heilbronn Memorial Lecture this morning, and I was delighted that you spent a few minutes talking about Louis. I know I met him once, and am sorry that I didn't have a chance to get to know him better. I'm going to cover a lot of ground this morning. It is my habit to try to stuff 20 pounds of material into a 10-pound bag, and I will do it again today. The consolation is that the PowerPoint, which is quite detailed, is something I'm happy to make available, and that can either be done through the World Affairs Council or anybody who sends me an email. I'd be happy to send a copy of it. So some of the slides will go by rather quickly. But you can have a chance to look at them later if you wish. I want to start with some main messages that whatever else gets lost in the detail, I hope will stick with you. The first one is that the widely used term global warming is in fact a misnomer because it implies something that is gradual, something that is uniform, and something that in the minds of many is benign. What could be wrong with a little bit of warming? And none of those things is true. It is not uniform, it is not gradual, and it is certainly not benign. I like to use the term global climatic disruption in preference to global warming or even global heating, which is maybe a little better. The second main message is that the disruption and its impacts are growing more rapidly than almost anybody expected even 5 years ago. Third message is that dangerous anthropogenic interference in the climate system, which is what the UN Framework Convention on Climate Change commits the nations of the world who ratified it, including the United States, to avoid, in fact, is no longer avoidable. We are already experiencing dangerous anthropogenic interference in the climate system. The question at this point is whether catastrophic interference in the climate system can still be avoided. Avoiding it is going to be an immense challenge, and I'll be talking much more about the dimensions of that challenge this morning, for the reason that we really will need large and early departures from what you might call the business as usual trajectory in energy use and land use and a variety of other things that are central to our way of life in order to have any substantial chance of avoiding catastrophic disruption. Next main message is that there is no panacea. There is no single silver bullet. There is, as I will argue later, a silver shotgun, a great many things that we can and must do. The most important single thing we need to do, and as quickly as possible around the world, is to put a price on emissions of carbon dioxide, which increase the incentives, therefore, to reduce those emissions. My last main message, which I will come to in detail at the end of the talk, is that the United States is at or near a political tipping point on this issue. We are very close to taking the sort of action that is required, in my view, and I believe, in addition, that after the United States moves, it will not be very long, no more than 3 to 5 years, before China and India will follow. It's a matter of great speculation in the climate change community. What can we possibly do to get China and India and Brazil and Mexico and Indonesia, the other large developing countries, to join in a global framework of greenhouse gas reductions? I believe that problem is becoming easier every day, and I'll tell you why. But I want to start with a very quick review of exactly what climate change is and what it means, because we can't really think sensibly about the solutions unless we have a pretty good understanding of the problem. And the first key point to understand is the difference between climate and weather. Climate is the pattern of weather, meaning the averages, extremes, the timing, the spatial distribution, not only of hot and cold, but of cloudy and clear, of humid and dry, of drizzles and downpours, of snowpack, snowfall, snowmelt, of zephyrs and blizzards and tornadoes and typhoons. And the point is that when climate changes, the patterns change. The global average surface temperature, which nearly everybody uses to talk about the magnitude and the pace of climate change, is just an index of the state of the global climate as expressed in those patterns. And the key point is that small changes in the index correspond to big changes in the patterns. The difference between an ice age and a warm interglacial is only 5 degrees centigrade in global average temperature. Huge difference in the patterns, huge difference in what the climate is, little bitty difference in average surface temperature. Climate change puts a great many things of value to us at risk. Climate governs, and so climate change affects the availability of water around the planet, the productivity of farms and forests and fisheries, the prevalence of oppressive heat and humidity, the geography of disease, what kinds of disease organisms and vectors can live in what environments in what numbers, the damages that we have to expect from storms, floods, droughts, and wildfires, the property losses that we have to expect from sea level rise, the expenditures we have to make on engineered environments, dams, dikes, irrigation systems, the amount of indoor space that we have to air condition. And it governs ultimately the distribution and abundance of species, the ones we love and the ones we hate. The Earth is getting hotter. This is the temperature record during the period, the last 125 years, when thermometer measurements were widespread enough over the land and over the oceans to meaningfully define a global average surface temperature. You can see it's a bumpy record, a noisy record. The uncertainty bars are shown in green there if you look closely. 2005 was arguably, although there's a bit of dispute about the competition between 2005 and 1998, arguably the hottest year on record. You can see that 2005 and 98 were very close. The 13 hottest years.
Oh, this is ridiculous.